Heat is transferred in 3 different ways. And you're going to need to know the 3 different ways. This is really important. It was important when we talked about convection currents that occurred in the mantle, and this is going to be important when we talk about how heat moves around in water and also about how heat moves around in the atmosphere. And this is the reason why we have weather on our planet, is because of this way that heat is transferred. So we're going to talk about each of these 3 ways. So the first way is that radiation moves energy from the sun to the earth. So radiation it moves in waves as it comes down. When the radiation gets to Earth, a few things can happen to it. It can bounce off of our atmosphere and go back out in space. It can get absorbed in our atmosphere, in the upper atmosphere, or it can pass through it and it can come down to the surface of the planet. When it comes down to the surface, a few things can happen also. It can get absorbed into the ground, it can be reflected off the ground, and then it can be absorbed in the atmosphere, or it can pass back out into space again, or it can get bounced back at it. So radiation doesn't just go in one direction, it can kind of bounce around all over the place. But when radiation actually makes it down to the surface of the planet, it warms up the surface of the planet. And when it does that, it allows the next process to happen. So because we know that when radiation comes down, it's coming in those waves, it comes to the surface of our planet, and now it's heat. And as it touches the surface of the planet, it's going to warm up whatever surface it happens to be that it touches. And as that surface warms up, it's going to warm the blanket of air that's right above the surface. I want you to imagine that if it's cold outside and you go outside and the sun is shining on the sidewalk and you were to put your hand right above the sidewalk, don't actually touch it, but imagine that your hand is right above it, and you can feel how it's warmer down on the sidewalk where the sun is shining than it is if you have your hand 5 or 6 feet above that, because the surface has warmed up and it's warmed that air that's right above it because the air is touching the sidewalk, and that's conduction. Conduction is how energy moves, by touching. So these examples have nothing to do with the sun, but if I touch a pot that's on the stove, it's going to be hot, right? And that's because of conduction. If I touch the part that's not actually touching the flame, like in this one here, I didn't touch down here, I didn't touch those flames, but this one heated up because of it. Cold day, I pour myself a mug of hot cocoa and I hold the mug in my hands to warm up my hands. That's conduction. So once again, the sun, the radiation comes down and it warms that surface of the earth, and if I touch that sidewalk, now my hands are warming because of conduction, because my colder hand touched the warmer surface of that sidewalk. Now imagine that my hand is air, okay? So as the air that's right above the surface warms, what happens to warm air? Where does it go? We know that warm air rises, right? So that warm air starts to rise, and it rises up until it cools, and then it can't rise anymore, so it's going to sink. And now we've got convection, okay? So our radiation has come down and it's warmed up that ground, and the air that's right above it gets warmed up and starts to rise. And as it rises, it cools, and then it starts to fall back down, and we get these circles because it's going to warm back up again as it gets closer to the ground. Much like when we talked about the mantle, right? And we talked about how the core was hotter and the crust was colder, and the warmer magma came up from the core and came up to the surface where the crust was, and it pushed the crust, but it cooled off, and so it came back down. These are the same convection currents that occurred in the mantle also occur in our atmosphere. Now, the difference here is that as warm air rises up, warm air can hold more moisture than cold air can. And so as it cools down, it can't hold that moisture anymore, but it's already in the air. So I want you to imagine that you have a sponge that has a lot of water in it, and all of a sudden it can't hold that water anymore, so the water's got to come out of the sponge, and it's going to condense, and it's going to make clouds, and it's going to rain. And so convection is the reason that we have storms, and it's the reason that we get clouds, is because that warm, moist air rises up, it cools down, it can't hold all that moisture anymore, and it makes clouds. We get wind because of this, okay? And we get clouds because of this. So without our energy transfer, we wouldn't have weather on our planet. It's circulating the heat in the atmosphere, which is good because we don't want one area to get way, way hot and another really cold. Now, I know the desert's hotter than other areas, but we're talking about something like Mercury that has no atmosphere, and the side of the planet facing the sun is hundreds of degrees Celsius, and the back side of it that's facing away from the sun is freezing. Our moon is the same way. not hundreds of degrees, but the front side of the moon is way warmer than the back side of the moon because there's no way for the air to circulate around because there's no atmosphere on our moon. So that's one of the things that makes our planet unique is we've got this atmosphere where heat circulates around.